Alright, let's have a quick look at how we find the gradient of these slopes. And remember, the gradient is simply the steepness of something, and I love coming back to this picture here, this picture of a street in New Zealand called Baldwin Street. It's actually the steepest street in the world, I think. And we know that it creates an angle with the horizontal of 38 degrees, okay? So across the horizontal here, if I had my street coming upwards, the angle that I'm actually creating is 38 degrees. And we know that's actually quite steep, right? In terms of an angle, it doesn't seem that much. But when you're physically at the place and you're looking up, it looks pretty crazy. I think there's some other pictures going on here. So I really love this picture, which you can actually see how steep this guy actually is. Okay, so that's looking at the gradient of something, and we know how steep it is, and we can determine that using the rise over run. And remember that in a mathematical perspective, we read the gradient from left to right. And if we look at these segments here, remember, if I read it from left to right, I can determine its gradient. I know that its gradient from left to right, if it's going up, it's going to be positive. And if it's going down, then the gradient is going to be negative. But I need to be reading it from left to right. That's really important. So this blue line here, I can see that this guy is just going to be positive. This guy here, this green line, when I read it from left to right, it's going down. So this has a negative gradient. Okay? And what happens if it's horizontal? Well, if it's horizontal, there's actually no steepness, is there? So I know that this is simply just going to be a gradient of 0. Okay? Sweet. I need some more board space, so let me let this go. So, find the gradient of these slopes. And it doesn't matter if we're not in a Cartesian plane, I can still find the gradient of any slope. And here's a few examples. There you go, there you go. So we've got 3 different scenarios here. This first guy, we've got like a car going up a hill, okay? And he wants to know what's the gradient of this slope. And we just come back to this definition, the rise over the run. How much do I go up compared to how much do I go across? So the gradient here is simply going to be 150 over 1000, okay? And I can simplify that out. What would I get? I'd get 0.15. And we actually like to leave the gradient as a fraction, so let's leave it as 3 over 20. Alright, see if you can beat me for these ones. Let's keep going. I've got a roof now, and I just want to look at the component which has a slope, okay? I can see there's a slope going on here, but I've got a whole lot of other measurements. So the only ones I'm interested in are the run, which in this case is 10 meters, and my rise, which seems to be 6 meters, but notice carefully, where is my slope? My slope is only starting from this point here, and going up towards the top. So if I know that this length is 4, and this whole length is 6, what would just be my rise? Well, my rise in this case is just going to be 2 meters, right? And that's just 6 take away 4. That's just that bit there. So the rise over the run, or the gradient in this case, is equal to 2 over 10. And that's just a gradient of 1 over 5. Cool. Last one here. I've got a slide, so someone needs to be sliding down it. Alright, so he's going down, and as he goes down, we want to find the gradient here. We want to know how steep this guy actually is. So remember, I'm looking at my rise. I can see I've got a rise of 6 meters, and I've got a run of 4 meters. That's just going to be 6 over 4, and that's just going to be 3 over 2. So this is a pretty steep slide. Okay? That's how we can find the gradient of any slope, okay? Even without a Cartesian plane. we can use these measurements that we're given and then simply substitute into our formula. Alright, now you've been finding the gradient of the lines on a Cartesian plane when you're kind of given a real grid and structure to it, but you can also do it just by simply looking at the coordinates you've got. Because remember, what is the gradient? The gradient is just the rise over run. And we can actually find this even without the grid here. All I want to look at is how high do I have to go compared to how far across do I have to go to connect 2 points that I'm interested in. Okay? And when I want to find the gradient of these lines, I can actually choose any 2 points on the line. But I've given you some points here, so make it a little bit easier. And some of you are wondering, okay, well, which way do I have to draw the triangle? It doesn't actually matter. You'll get the same answer. And let me show you how. So if I just look at the rise first, I want to compare these 2 points here, A and B. And they have the coordinates here. And I can see that the rise, well, that's simply going to be 3. And the run, well, I want to look at the coordinate. So I know the x-coordinate of this guy is 2, and the x-coordinate of this guy is -1. So I can see that I'm going to have to go across 3 for my rise over run. Okay, so the gradient in this case is just equal to 3 over 3, which is just 1. Let's see what happens if I went the other way. Sorry. If I went the other way, if I do my rise up here, well, this length is still 3. And going across, I still have a run of 3. So it doesn't actually matter which way you draw your triangle to see your rise over run, you'll still get the same answer. Okay? But one thing to make sure that you're careful of is that we're looking at the slope. So if we read it from left to right, then it's a positive gradient. But if we read it from left to right and it's going down, then it's a negative gradient. Okay? Let's have a look at this next one. So here I've got a point A, which is 0, 0, the origin, and B, which is the point 5, 4. So just to make it really clear, I've got a x coordinate of 5 and a y coordinate of 4. So I can see that my rise over run, well, how far up am I going? I'm going up 4 units. And how far across am I going from A to B? Well, I go across 5 units. So my gradient is just equal to 5 over 4. And we can leave it as a fraction. And this guy going from left to right, it is going up, so this is going to be a positive one. Last one here, so I want to be careful. I can see already, reading from left to right, it's going downhill, so it's going to be a negative gradient. Okay, I want to make sure I put that in my final answer. But let me just do the rise over run first. So I know I'm going up 2, right? Because I look at B, I look at the y coordinate of B, and I see, oh, I have to go up 2 units, get up to A. So my gradient is equal to 2 over my run. So to go from this point here all the way across to B, well, that's a distance of 3, because that's my x-coordinate there, okay? That's my x-coordinate there. So I really want to pay particular attention to how far across I need to go. The gradient would be equal to 2 over 3, but that's not quite the final answer, is it? Because when I read it from left to right, I'm actually going downhill, right? I have that negative gradient. So if I put a negative in front of that value, that's the final answer. And as you're working through these and finding the gradients with the rise of a run, think about if you can actually find it just using the coordinate values there, not having to draw the triangle and write it out each time. Because although that's really clear, it does take a bit of time. So in the investigation, if you have a go at it, you'll see that there's actually a way to do it.